In this video, we're going to talk about the problems from the study guide for sections 4.6, 4.7, and 4.9. So let's look at number 1, which is in the upper left corner. And here you're asked to simplify these radical problems. And let's start with number 1, or the first part of number 1. What do you think we should do there to simplify that y to the second power under the radical to the second power? If you said cancel the exponent and the radical, I agree with you. That's exactly what you should do, because they are opposites and here they have the same power. So cancel these two out, and the only thing that's left is just the y. That was easy. What about for the second part of number 1? What do we do here? Same thing as before, because don't forget, if there's nothing in front of the radical, you assume it's a 2, which means it's a second power radical and it's a second power exponent. So once again, gone, left with just the a. And the third one, I don't have to ask, it's just like the one before. Cancel the radical of the second power and the exponent of the second power to get the m. So here are the three roots, the three answers. In this case, these are squared roots. Questions on number 1? Alright, moving on to number 2, which is in the upper right corner. Here you're asked to write down exactly what you should be doing for each step of the problem. So I don't want you to solve it, I want you to tell me verbally what happens in each step. So what's step 1? What should be the first thing that I do? Well, if you said break up the problem into 3 different parts, I would agree with you. And I'm going to write exactly that. You might have said something a little different, but give or take it should be close. So break up, that's a terrible. Break up the problem into 3 parts, or into 3 radicals. Again, you could have said a few things here, but all of those would work. What should be my second step now that I've broken the problem up? Well, my second step would have been, after I broke this problem up, to get the exponential form of 49, or put 49 in exponential form. So put or place 49 in its exponential form. And again, this is just one thing you could have wrote there, not necessarily all the answers are going to look exactly like that. That's just what I choose to write. And what's the last thing you would do after you broke these up into 3 parts and placed 49 in its exponential form? You would cancel the radical with the exponent. And you would do this 3 times for each different part, and that would solve your problem, because they're both second power. You can cancel the radical with the exponent. Questions on number 2? Let's take a look at number 3, which is on the upper left corner here. And here this was essentially fill in the blanks type of a situation. So let's go ahead and fill in those blanks. Exponents and blank are opposites. What's the opposite of exponents? Radicals. If they are the same power, they will blank each other out. What should I use there? Cancel from the previous problem. Okay. The answer to a radical and here I did have room, so its simplification is called what's the answer to a radical problem? We call them roots. A root is an answer to a radical problem. The answer to a second power radical simplification, so this is a specific type of a radical. It's a second power radical, and we give it a specific name. It's a specific type of a root. We call these square roots. So a square root is just like any other root, but it's specifically an answer to a second power radical. So if someone asks you what a square root is, they're asking you to find the answer to that problem when you put it under a second power radical. Questions on number 3? Alright, let's take a look at number 4 then, which is on the bottom right corner for me, or right here. And here you are asked to find the square root. So can someone tell me what should be the first step for all of these problems, all 3 right away? What should I do first? If you said put them all underneath the radical of second power, I would agree with you. Because if they're asking for the square root, they automatically want you to find what that is under a radical to the second power. And you can write that too, or you don't have to. 100% optional. So that's my first step, and I do like to write this step out. Okay, what should I do next? What should I do next? For all 3. If you said write them in exponential forms, totally agree with you. And what are the exponential forms for all 3? For 36, it's 6 squared. For 81, it's 9 squared. For 121, it's 11 squared. And yes, they all have their negative counterparts. Remember, I could have used the negative version, negative 6 squared, negative 9 squared, negative 11 squared. But unless you're told otherwise, just stick to the principal or the positive roots. And what's my last step? My last step is to cancel out the radical and the exponent. They're the same power, so gone, gone, gone. And now you're just left with the answers. So these were just like the problems from number 1, except you had to do a little bit extra work. That's it. Questions on number 4? Alright, for number 5, this is the first of my fix my mistake problems. There's 2 on the study guide. And you're supposed to find where I made a mistake. So can someone tell me where that mistake was made? Right here. That was my mistake. And what was my mistake? I have an exponent to the 3rd power. This is a radical to the 2nd power. You can't cancel out a 2nd power radical and a 3rd power radical like this. If this radical had a 3 right there, if it was a 3rd power radical, that would work, but I do not. So that was my mistake, and you can write down I cannot cancel different power exponents and radicals. Questions on 5? Alright, let's take a look at 6. Number 6 was our first estimate your root problem. So 30 is not a perfect square. So you have to find 2 perfect squares, one right below, one right above. So what are the 2 perfect squares? One right below 30, one right above 30. Well, the one right below it is 25. The one right above it is 36. What are the exponential forms of 25 and 36? For 25, it's 5 to the second power, or negative, but we're going to go with the positive, and 6 to the second power. And so what's the answer to this simplification? Just a 5, and right there is just a 6. So what would my answer be? If 30 is between 25 and 36, and 25 gives you 5 and 36 give you 6, so what is approximately 30's value? 5.5. Right in between the two. Questions on 6? Let's take a look at 7. Same thing, you're asked to find you're asked to estimate the root. Answer. So and 138 is not a perfect square. So what are the two perfect squares above and below 138? Well, the one right below it would be 121, and the one right above it would be 144. What is the exponential form of the two? For 121, that's 11 squared, or 11 to the second power. For 144, that is 12 squared, or 12 to the second power. And what are the answers to these two? 11 and 12, because the radical and the power cancel out, leaving us with just the base. So if 138 is in between 121 and 144, the simplification to 138 should be approximately 11.5. It's a little closer to the 144, but it's probably more like 11.6, but 11.5 works for us. Questions on 7? Alright, then let's take a look at number 8. Number 8 is my other fix my mistake type problem. So can someone spot my mistake and tell me what did I do wrong? My mistake is right in this line. The entire line is wrong, because I should have chosen 36 as the perfect square that's right below 42, not 25. 25 definitely is below 42, but is not right below that. 36 is closer to 42. So if I did that, so I'm gonna hover over right there, I would have written 36, which yields 6 squared as exponential form, which yields a 6. So my answer would have been between 6 and 7, not between 5 and 7, in which case it would have been approximately 6.5. So that was the mistake that I made, and that's what the mistake led to. Any questions on number 8? Number 9, you're asked to find the missing side of that right triangle. And I know it's a right triangle because it has a right angle. It has that square that denotes right angles. So what would I do first? Well, first I'm going to write down the Pythagorean Theorem. Given to us by the Greek mathematician Pythagoras. Okay, so now what's A, what's B, what's C? Well, C is always along this side. That's easy. That's C. Oops. A is always the shortest side, which this looks like it's the shortest side. So the missing side is B. Alright, what do I do next? What's my next step? What's my next move? My next move would be to plug in what I know and then find what I don't know. So I know A. A is 5, so instead of A squared, I'm going to write 5 squared. I don't know what my B is, so I'm going to keep B as just B. But I also know what C is. It's 13, so it's going to be 13 squared. It's not so bad. It's not so bad at all. Next step. What's 5 to the second power? 5 times 5, 25. Once again, I don't know what B is, so I'm just going to leave that B. Well, that rhymes. I don't know what B is, so I'm going to leave that B. And what's 13 to the second power? 169. What's my next step? My next step is to isolate the B. So I'm going to take away the 25, so it's all nice and isolated. How do I get rid of that 25? By subtracting 25 from both sides, of course. And when I do that, B squared equals out to what exactly? $144, you say? You're correct. What's my next step? Well, I don't want B squared, I want B, just B. So I'm going to get rid of this power of 2 by taking the radical of second power from both sides. And again, it's second power even though I didn't write the 2. What is the exponential form of 144? 12 squared. So now I know that B equals to 12 squared, and then I'll cancel out the root and the radical. So B equals to 12. Makes sense. It's the second longest side. It's not quite as long as the hypotenuse, but it is the second longest side. Any questions on number 9? Alright, let's do number 10 then. Number 10 is very similar. Again, you're asked to find the missing side. That's not a problem for us at all. So let's go ahead and do that. Let's find the missing side. First, I'm going to write down the Pythagorean Theorem. And again, you will get this memorized. It's one of the easiest formulas in math to memorize. So which one's A, which one's B, which one's C? Right off the bat, I know C is the one that's missing because the hypotenuse, the longest side, is in front of the right angle. So that's C, the missing one. And that leaves me with A being the shorter one. A is short. Nothing A can do about it. And B being, well, the middle child. Plug them in. See what happens. We have 5 squared instead of A squared. We have 7 squared instead of B squared. And we still have C squared because C is missing. What's 5 to the second power and what's 7 to the second power? 5 to the second power is 25. 7 to the second power is 49. Okie dokie. So, what is 25 plus 49? What is 25 plus 49? It's 74. Okay, so c squared equals to 74. How do I find c? By taking the second power radical from both sides. So now I have c. I know c is the radical of second power of 74. That's terrific. But 74 is not a perfect square. So what are the two perfect squares that 74 falls between? .64 is the one that's right below, and 81 is the one that's right above. What are the answers to those two? 8 and 9. So what's in between 8 and 9? .5, and that's my answer. C is 8.5. Makes sense, it's the longest side, so that it passes that check, at least the logic check. Question to number 10. Number 11. And number 11, you're asked to find if these three sides make up the Pythagorean theorem. How do I do that? How do I check to see if they work or not? Well, I write the Pythagorean theorem and then I plug them in. A squared plus b squared equals to c squared. And the longest is c, the middle child is b, and the short one's a. So just plug them in. 6 squared plus 8 squared equals to 9 squared. So what's 6 squared, what's 8 squared, what's 9 squared? Six squared is 36. 8 squared is 64. And 9 squared is 81. What's 36 plus 64? A 100. Is 100 equal to 81? No. So, nope. You're not a right triangle. Get out of here. Questions on 11. Then let's do 12, our last problem. It solves just like 11. I'm going to write up my Pythagorean theorem, then plug my values in, and if it works, it works. If it doesn't, oh well, too bad. Too sad. Or so sad. Oops, I kind of jumped the gun there. My bad. Not quiet. That's what it's going to be in a little bit. So that's my Pythagorean theorem. Now I'm just going to plug my numbers in. Shortest side is 3, so that's going to be my A. The middle side is 4, it's going to be my B. And the longest side, the hypotenuse, is C. What's the answer to 3 to the second power, 4 to the second power, and 5 to the second power? Should be easy. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And what's 9 plus 16? It's 25. And hey, it equals to 25. Yay, it works. Lucky us, I think. Alright, So 12 worked out. It's a right triangle. 11 did not. It's not a right triangle. Questions on 11 and 12? Thank you very much.